incremental learning. Sure. The goal is for us to avoid this thing from happening so that we are learning incrementally. So what if this actually happens, that we forget everything from the previous task, which is called as catastrophic forgetting, which we'll come to. That's not what you want. That's not the requirement that you are looking for. Okay. So just going through the details of this particular thing. So initially, this is your network. You've added the nodes corresponding to these new classes, and then you're going and changing all the parameters of the network or a subset of the parameters of these layers. Okay, so what happens in this particular case is you obviously get suboptimal results. Okay, the other naive solution that we can think of is this case of feature extraction. So what we're going to do is, okay, I have my network that is given to me, and what I'm going to do is not change the parameters of any of the previous layers. So I'm just going to simply treat my neural network as a feature extractor, and I'm only going to learn the last layer of the network so that it can learn the new task. Okay? So here we are saying, okay, we're going to keep the network fixed. We're just going to simply learn the new part of the network that I have added. Okay? So here, what do you think? Do you think this is a good idea or not? Sorry? I could hear some not. Okay, not good. How many say yes? Is this good? Any yeses? Okay, 1, 2, okay. Why? Why is this good? Wait.
So in the second case, we are keeping the common part of the network as fixed. So this acts as a feature extractor. So we are essentially getting the our final network to perform better on the first task. So that's an advantage in the second case. In the first case, we are not making sure that this particular network will work on the task that it has been trained on the earlier task.
So yes, between the two, yes, the advantage maybe is that here we are not completely changing the network by keeping the network fixed, but then there is a bigger disadvantage though, which is that what you have, the features that you've learned, are specific to the first task. Right? So all of the initial layers of your network are essentially are learned from the first task, which means if the second task, in particular when the data is very different, it's perhaps from a different domain, it won't be able to capture the essence of all of this data accurately. So that is I think what you're saying is a positive point, but the negative point is much more dangerous in this particular case. Okay, so that is what is typically referred to as sort of catastrophic forgetting, because you're learning. You're learning everything specific, the last layer for this particular thing, and the features are not adapted to this new task that you're learning. Okay, so let's take a computer vision example to see what exactly happens when you're doing, let's say, one of the naive solutions. So here I have a standard network where I give as input images, and my goal is to essentially detect different kind of classes. So in this example, I'm showing person, and I'd like to find the bounding box enclosing all the people in the scene and other classes as well. Okay. So here in this example, we have 3 classes. So that is my initial network. And now what I'm going to give you is new training images which corresponding to new classes. So in this case, a new class, which is that of horse. So I'm going to provide you lots of images, positive examples of horse. And then I'm going to ask you, we want to extend this network, which was for 3 classes initially, to the 4th class. So essentially a set of 4 classes which includes person, horse, etc. Okay, so now given, let's say, the same test image or a different test image, what we'd like to do is detect, for example, in this case, horses. Okay, but the question is, are we still able to detect person? Or in other words, how accurately can we detect the person? Okay, so let me, for the illustration purposes, call the top network, which is my old initial network, as network A, and my bottom network, which has been extended to this new set of classes as network B. Okay, so network B is the one which contains all the classes that I'm interested in, and I'd like to see what is the performance difference between these two. Okay, so as a comparison, I wanted to put the golden baseline, which is the case where you have the initial old network A, but we have trained it on all of our 20 classes. Okay, so you have classes 1 through 20 from the entire data set, and this will essentially serve as a baseline for us to see how well or poorly we are performing, when we look at network A and network B. So, and then I've looked at the performance separately on the first set of 10 classes, 1 through 10, which I called as my old classes or old tasks, and then I have my new tasks or new classes, which is from 11 through 20. So that's just the average on all these classes, and all represents the average on the entire set of 20 classes. Okay, I'm going to compare the performances on these three kind of measures. Okay. So the first one is the case where you have, the network A, the initial network, which is trained on only 10 classes. Okay, so which means you have lesser amount of training data, and you can only get the performance on the old classes because it hasn't seen any of the new classes, so we cannot say anything about the new classes. So the performance here is slightly lower because you have lesser amount of training data, so it is natural for the performance to fluctuate a little bit and to have a lower performance. So now the next question is, what would happen when you add the new set of classes representing your network B from these 11 through 20? So any guesses on how the performance would be on, let's say, the old classes and the new classes, and let's say the overall? So let's say on the new set of classes, how would the network B perform? So you have training data for these new classes. You're essentially fine-tuning your network, let's say, to see how it extends to these. So in this case, how well do you think network B will do? Just a ballpark figure. Sorry? It will increase performance on new classes, okay, but it will be roughly how much? Will it be 80 on new classes? Okay. Any other numbers? 50? 50 to 60, so roughly lower than the 71 you're saying, okay? Sorry, yeah, okay, so around, let's say, 70 or slightly lower you're saying, okay. What about, let's say, the performance on the old classes? How much do you think will it be? Will it be, sorry? It will decrease a bit, okay, to how much? Around 60 something, okay? 50 to 60, okay. And then, okay, so you're saying both of them will kind of go down, and obviously, which means that the overall average also will go down. But what actually happens is a much bigger drop in this. So here I'm showing kind of the extreme case of fine-tuning, where I fine-tune, let's say, most of the layers. I think it's all but one layer which have been fine-tuned. So the entire network has been updated, right, with this new data, which means the network has done reasonably well. Okay, it is lower than 70, but you have seen not all the data at once. So it's lower than 70, but it's not dramatically different. But what's even more disappointing is the performance on your old classes, right? So it has catastrophically forgotten all of your old classes because you're only training with the new data, and then these models, neural networks, or any machine learning model in general, if you don't take the appropriate care to remember your old data or the old model that you have, it will completely forget it, pretty much completely forget it. And it's pretty much noise what you get from, let's say, 12-13% from over 10 classes is roughly just noise. Okay, so which means that the combined effect of this lower performance on the old set of classes leads to overall performance which is not ideal. So simply put, why is this happening? Because this is mainly happening because we haven't really given any guidance to our network or the machine learning model that we have to retain the old classes, right? What we are simply doing is just providing it with new data and just asking the network to learn all of these new classes, but then we didn't provide any mechanism to kind of retain all the information, as somebody said, memory, for example, to remember all the things that you've learned in the past, right? So that is the thing that we want. Okay, so just to maybe kind of slightly formalize, what are the things that we would like to expect, the desiderata for this incremental learning setup is, basically we'd like to learn one task after another, or let's say